My name is GS Khalsa. I work for VMware in technical marketing. And you hear technical and marketing, and those are two terms that usually don't fit very well together. But focus more on the technical, less a bit on the marketing. My role is creating enablement material, so white papers, blogs, things like that. Stuff that you'll read on VMware's website, as well as enabling material for internal VMware people and your partners to communicate better with you about our products. Really excited about our session today, and really happy that I've got who I have with me as my co-presenter, actually really presenting most of this session, and I'll let him introduce himself.
Hello everyone, my name is Alexey Pershin. I'm one of the lead engineers on the Site Recovery Manager project. I'm all the technical, no marketing part.
Okay, so let's get it going. So just make sure you read all of these words. We'll have a test about this at the end. So what are we going to talk about today? We are going to go through why we want SPPGs and what they are. That's the portion that I'm going to cover. Alexey's going to do a deep dive and some demos, and then we'll just kind of recap things and make sure that we leave time for Q&A. So just real quick, I'm assuming that everybody here already has a decent understanding of SRM, so I'm not going to talk a lot about what SRM is and how it does what it does, but just the 30-second elevator pitch on SRM: automation and orchestration solution for disaster recovery, automated runbooks, and to me the coolest feature of SRM is that ability to non-disruptively test your DR plan as often as you need to or want to. So with that, since we're going to be talking about protection groups, let's just level set on what is a protection group. So a protection group is a group of VMs that you want to recover together. So you can set that up however you want, whether that's by application, by department, whatever makes sense to you, you can organize your VMs as you desire. The thing that the different types of protection groups are going to dictate a little bit, though, of how you organize that, and that's what I'll get into. One thing that I just want to be clear about, though, is with protection groups, a VM can only belong to a single protection group. We'll talk about recovery plans in a little bit, and that's a little bit more flexible, but one VM, one protection group. So first off, we'll talk about vSphere replication protection groups. So vSphere replication is, from a protection group standpoint, is the easiest type of protection group. Because vSphere replication protection groups are based on vSphere replication, and vSphere replication is not tied to storage. You can replicate any VM with vSphere replication, doesn't matter what the storage is on the target site, doesn't matter what it is on the recovery site. However you're replicating, it doesn't matter. So when you organize your VMs for vSphere replication, just pick the VMs and group them in the way that makes sense to you. Now, array-based replication is a little bit more complicated. So here we're talking about replicating LUNs or data stores, depending on if you're using NFS or if you're using iSCSI or block level storage. So you're going to start off with your LUNs, and you can have consistency groups as well. So if you have a group of LUNs and you have a group of VMs on those LUNs or data stores that you want to recover together, you can organize them in a consistency group from a replication standpoint. You're going to map those to data stores from the vSphere standpoint, and then the VMs that are on that storage, that is your protection group. So when you think about how do I want to organize my protection groups, which VMs do I want on those, that's based on your storage. And I get asked a lot, can I have a VM, I've got 10 VMs that are on this one LUN that are part of my application. I want to protect those, but I don't want to protect these other two VMs that are on that same piece of storage. How do I do that? And the answer is you don't put them on that LUN, because that LUN is going to replicate, and when you fail over, SRM is going to expect that all of the VMs that we're running on there are turned off, or are able to be that LUN is able to be disconnected from those hosts, and if it's not, it's going to cause problems. So really clear about where you have to put your VMs from a protection group standpoint when you're dealing with array-based replication. So some of the challenges with array-based replication are that when you want to protect a VM, there's a real step-by-step process that you have to walk through. So you want to protect a VM, you're going to add it or deploy it to that replicated data store, and then you're going to go into SRM, you're going to pull up that protection group, you're going to edit it, you'll see that list of VMs that are available there, you check the box next to the one that you want to protect, go out, then you're going to configure protection for that VM. And you got to do that for each one. And while that works at smaller scale, it's not very dynamic. And there's not a whole lot that you can do to automate that process. And it gets even more so when you talk about data stores or you talk about removing VMs. You know, that similar process that you've got to go through if you want to change things from a data store standpoint, you want to remove VMs, whatever you want to do, it's fairly involved what you have to work with. So the solution to that, what we've come up with is in SRM 6.1, we're enabling what we're calling storage policy-based protection groups. And so the idea here is that you have a storage policy that's associated with a data store, and when you associate a VM to that policy and you place it onto the data stores that that policy is compliant with, or that are compliant with that policy, that VM is automatically protected. And that's all that you have to do. And it flows the other way as well. When you want to unprotect a VM, you disassociate it from that policy, remove it off that data store, and it's unprotected. The whole thing is automatic, dynamic, happens automatically. So helps with your OpEx, makes it easier to provision VMs, easier to protect them, easier to unprotect them, and the same works with data stores as well. So before we get into the deep dive and the demo, just really quick, this isn't a what's new in SRM session, but I'll just really quick talk about the other features that are new in SRM. So SRM now supports stretched storage. In the past, you had to make a choice between either stretched storage or SRM. Now you can utilize stretched storage with SRM, so you get all of the benefits of SRM, which is DR orchestration and automation, your failover plan happening the same way every time, the ability to non-disruptively test it, along with the benefits that you get from stretched storage, which is zero downtime disaster avoidance. So the other one, that session is tomorrow, 2 to 3. NSX integration is another big one. NSX now supports, this is NSX 6.2, now supports the ability to span vCenters. Previously, NSX was a single vCenter concept. So NSX now supports the idea of primary and secondary NSX managers. From an SRM standpoint, the big change is, and it ties in really nicely to SPPGs, is if you're utilizing this new concept called a universal logical switch, which is a spanned layer 2 between vCenters, something enabled by NSX, if you're utilizing that and you have a VM that's connected to that port group in one vCenter, when you move it to the other vCenter, you don't have to do any mapping. So that mapping is handled for you automatically. So again, you provision a VM, you protect it with SPPGs. If it's using that NSX universal logical switch, you don't even have to do any mappings to get it mapped over to your other site. Got a whole bunch of other smaller improvements. There's a session Wednesday, 11 to 12, that's going to cover that. And then we also have a session, and Alexi is actually presenting this one as well, that's DR automation with vCloud Air. And so that's the new product that we announced, SRM Air, which gives you SRM-like functionality utilizing vCloud Air DR. So at this point, we'll let Alexi dive into the deep dive and demo.
Okay, let's clear out some terminology. The term that GS used a few times, SPPGs, stands for Storage Profile Storage Policy-Based Protection Groups. I'm going to use this term throughout the presentation as well. This, in comparison to the groups that we already have, sometimes called them VM protection groups, VMPGs, or just legacy protection groups. And before we go into that, let's define what do we mean by storage profile storage policy. A storage profile is essentially an indirection layer between VMs and storage. So it's a layer that allows the users to provision VMs without knowing explicitly which data stores to pick. Essentially, the tasks of defining which storage is good, bad, gold, silver, whatever you need falls into the arms of storage administrator, and VM provisioning goes to the hands of the actual users of VMs. And the way it works is that you create a storage profile and then you assign a tag to it, and I'll show a little bit later what it really means. And then when you create data stores, you attach tags to them, and that's how the storage profile knows which data stores should belong to this storage profile. And then when you provision VMs, you really pick a storage profile, and then that automatically picks one of the data stores, and you can override which one you want. If you're fortunate enough to have an array that supports VASA integration, then instead of tags, you can use capabilities that are exposed by the array, and those are array specific. And if you're looking into future, things like vVols, they will only be possible through storage profiles. And then storage profiles are meant to be dynamic, meaning that as VM moves, they can come out of the data stores that are meant to be in the profile. vCenter has ability to run compliance checks periodically and flag VMs that are no longer compliant and move them around. With that, let's show a little demo how this works. So what I'm going to do is first I'm going to create some tags and tag categories. Tags is just basically a string, and the category is a grouping of tags. So I go to tag UI, and then I'm going to create a tag category. So I'm going to pause here for a second. A tag category, you can think of it as just a group of tags. There's a couple of key things that you need to set for a tag category other than its name. One is whether it's a singular or plural when assigned to a given object, meaning that if you have a singular tag, what it means is that if you pick a different tag on the same object, the previous tag will get automatically erased. And also you get to choose which objects particular tag category is allowed to be assigned to. So here I'm selecting just one tag per object, and I'm saying only assign tags to data stores. So once I created a category, now I can go to the UI to create a tag. So, and for tags, I really just pick a name and I pick a category, and then that's it. So now we can see that I created a tag. So next, I'm going to create a storage profile. So I go to the policies UI, and then I'm going to create a storage profile. I'm going to pause here for a second. The way storage policies, storage profiles are composed, they consist of rule sets. A rule set is a collection of rules that are applied using AND, meaning that a data store will be in a profile if all the rules in a rule set are satisfied. You can have multiple rule sets that are applied using OR, meaning that if a data store satisfies rule 1 or rule set 1 or rule set 2, it will be in a storage profile. As I mentioned earlier, if you have an array that supports VASA integration, here you would be able to select some capabilities that are coming from the array, and vCenter has ways to discover it. So in my case, I'm using tags. So I'm saying a tag-based rule set, and I'm picking just one tag. What it really means is that any data store that has this tag assigned will be considered a part of this profile. And here you can see that vCenter already categorized some compatible and incompatible data stores. And here you're probably wondering, hey, wait a minute, what just happened? There is already one data store that is considered to be compatible with this storage profile. I actually cheated a little bit. After I created tags, I also assigned one of the tags to the tag to one of the data stores, and that's why this data store is here. I will show you later how to do it, but for now, just bear with me. So after this, the storage profile is done, and I'm going to show how to use it in a sentence, so to speak. I'm going to vCenter, and I'm going to create a VM. And the process for creating VM is really just the same. You just go and configure memory, CPU, disks, and whatnot. There's nothing really special here. So just bear with me for a moment. So here I'm just picking the name and the cluster where it should be. The important part will be when I select the storage profile that needs to be used for. And here, this is where I'm going to pause for a second. So here, this is where I select the storage policy. And you will see that I'm picking my profile, and you see there's a compatible and incompatible data stores. And I'm going to put it on one of the compatible data stores. And then after this, I'll just walk through the normal creation procedure. So for the purposes of saving time, I'm just going to scroll a little bit faster. So, okay, then now this virtual machine is created, and it should be assigned to the storage profile that we just created. Now we're ready to talk about storage profile protection groups. What is an SPPG? SPPG is a new type of protection group that we're introducing in this version of SRM. The way you define it is really just a collection of storage profiles. SRM is going to monitor all the VMs and data stores that reside in those storage profiles and will automatically protect them. And unprotection will be done, as GS mentioned earlier, it will be done automatically. The moment you would remove a VM from a storage profile, it will be automatically unprotected. Keep in mind that SPPGs only support array-based replication. They do not support vSphere replication. For that, you need to use VM-based protection groups. And since we're talking about automatic protection here, it's really important for you to understand that in order for SRM to protect a VM, it needs to know a lot about this VM. And the most important pieces are actually not what happens on the protection side, but what happens on the recovery side. We need to know where the VM needs to be placed, which networks it needs to be attached to, which storage profiles it needs to be attached to. All of this information comes in the form of inventory mappings. You map networks from one side to the other side. You map storage profiles from one side to the other side. And we use that as part of the failover. The UI can help you set up these mappings based on names, but it's your responsibility to revisit them periodically to make sure they're up to date. All the network resource pool and folder mappings, they're shared with VM-based protection groups, but the storage profile mappings, obviously, they're used only for SPPGs. Keep in mind that we're going to use all these mappings for SPPGs only as part of the failover or test failover. And at that time, you might have surprises. And obviously, if this happens, we have built-in protection to deal with this. And the way it works is that if as part of the failover, we discover that one of the mappings are missing and we don't know where to put the VM, we actually go and add what we call placeholder mapping, saying that this resource pool doesn't have a mapping or this network doesn't have a mapping. And then we fail the failover workflow. After this, you go to inventory mappings and map those entities to what you want to be used as part of the failover. And after this, you rerun the failover. Obviously, this can be done if the protection side is already down, because we're expecting a disaster recovery case. And that's why the test failover is extremely important for SPPGs, is because this is your chance to make sure that all your mappings are correct. If you don't do that, then you're opening yourself to surprises as part of the failover. Obviously, we have ways to deal with it, but that's time. If you limit it on the recovery time, you will have some surprises from your boss as well. When it comes to automation, it's important to as many things as possible. One of the things that is difficult to automate is the IP customization. We assume that across sites, the VMs are going to be using different IP addresses. Yes, you can go to each VM and then configure them as part of the recovery plan, but this is a bit cumbersome and requires some work. The best way we think to deal with it is use IP-based network subnet-based rules that basically specify how you're going to map IPs from one network to another. So with that, let me show you how this is actually going to be done.
Just one thing real quick, anybody that's standing in the back, there's seats up here in front if you want to have a seat. You're welcome to stay back there too if you want.
So first I'm going to configure network mappings, and the way it's really, if you are naming things in a sort of comparable way, so you can just pick a data center on one side, data center on another side, and here we're going to map the two networks, VM network, just by name. And that's as easy as that. And obviously, so let me pause here for a second. Here on this side, there is also one more parameter that you need to configure, which is the test network. This is a network that would be used as part of the test failover because we assume that when you do testing, you don't want your test VMs to interfere with your production. And then we automatically configure reverse mappings, or you can do them manually if you want. And here, I'm going to actually go into deep detail here, but here there is a place where you can configure subnet-based rules for configuring. It's basically for any VM. Let me pause here so you can actually see on the screen. For any VM that resides in, let's say, network 123.x, when you move it to the recovery side, you can change the IP address in a particular pattern. This way, things will be automatic. So then I'm going to configure folder mappings. Folder mappings is basically the same. You just, most cases, we expect you to match them by names.
And this is the automatic mapping is something that's new in SRM 5, I think it started in 5.8. And it just makes the whole process of mapping a lot easier. If the items that you're mapping have the same name at both sites, you have the option of automatically mapping those. One thing to just be clear about though is that's automatically helping you make that connection. If you add additional networks after you've done this mapping, you're going to need to go in and map those as well. It's not going to automatically, dynamically add additional mappings. It's just automatically finding a match when you do that mapping.
Right. So. And here I'm already proceeding with resource pool mappings. Those become very important when we start talking about which host the data stores are going to be mounted on. And I'll talk about it later. So for storage profiles, I did a manual configuration because I named the profiles differently just to prove the point. So at this point, once this is done, all the mappings are configured. Okay, so let's move on. So now let me show you how to create a storage profile protection group. This is actually the easy part. Once you configured all the inventory mappings, creating an SPPG is easy. All you go is just click a button and then you specify the name and then you pick which storage profiles you want to protect. So here you pick which direction you want to go, and then you pick storage profile-based protection groups. And I'm picking one profile, but you can pick more than one. And at this point, we have an SPPG. And if you remember, we had a data store and a VM in it. And here, both the VM and the data store, as you can see in the list of consistency groups, both of them are already protected. And really here, I didn't actually cheat. It's all done automatically. That's the point of this. So the next step is to create a recovery plan. I'm not going to show a demo here because this is pretty much the same as in SRM today. The only difference is that we're introducing a new type of recovery plans, which can be used only for SPPGs. And when you create a recovery plan, you just pick a list of SPPGs. And after this, all the VMs, all the consistency groups will be automatically put in this recovery plan. And just as with regular VM-based protection groups, you can put multiple protection SPPGs into one recovery plan, or you can share SPPGs across recovery plans. This is useful sometimes if you're trying to create recovery plans to recover your entire data center, or one rack, or some variations in between. Other than the difference of protection groups, the two types of recovery plans are all the same. They support priority tiers, dependencies, callouts, scripts, customization, everything that you know SRM does. And this is the reason why SPPGs are created is automatic protection. The idea is this. Imagine that you have a data store, and you have a storage profile with a tag. When you assign a tag to a data store, the tag in the profile and the data store get matched by vCenter, and from this point on, the data store is considered to be a part of the profile. When you provision a VM, you explicitly specify the association between the storage profile and the VM by picking the storage profile, and then the VM get automatically placed on one of the data stores. When you create an SPPG, you pick a storage profile, and then we traverse all these links to pick the VMs and the data stores. And we do this automatically in the background. So whenever new VMs come in or new data stores come in, we automatically protect them. And then we continue monitoring for this to make sure that everything stays protected as it goes along. If the VMs is removed, then we unprotect it and things like this. So let me show you how this actually works. So what I'm going to do is I'm going to new data store, a second one, and I'm going to assign a tag to it. And that's pretty simple. You just find a data store, and then there's a list of tags that you assign. And I'm picking my category, and I'm picking my tag. So this is the tag I created earlier, and now I'm going to assign it. And right now, this data store is actually already protected by SRM. It happens really quick in the background. Before I go to SRM, I'm also going to provision a new VM on the storage profile. And this process will go just like earlier. So I'm going. So the same process just as before. The interesting part happens here. So when I pick the profile, notice that now there's two compatible data stores. And vCenter actually picked the second one that I put in the profile just now because it has less provision space, which means more free space. It's all tiny VMs, that's why the column is in gigabytes is the same, but the provision space is actually less. So I'm agreeing with the choice that vCenter did, and then after this I continue on. So, and then this process is basically the same, so let me just skip through this. So now, I skipped to the part where the VM was already created. So now I am actually going to go to SRM, and you will see that both VMs are now protected and both consistency groups are protected. In my case, I have a consistency group for each data store independently. See, both VMs are here, and both consistency groups are here. So in addition, I'm going to recovery plan, and as you can see, the two VMs are automatically placed here. And normally, if you were doing this manually, this is where you would come here, and then you would have to configure IP customization for each VM, configure dependencies, and things like this. And that's why if you really, as an SRM administrator, you don't want to be touching this stuff ever, you want to make sure that things are automated. You either use NSX spanning networks or use subnet-based rules for IP customization. You probably want to use tiers in way to partition VMs during the recovery. So speaking of recovery, just to recap, what is it you can do with recovery plans and protection groups? It really is just the same as what SRM does today. There's several workflows. The first one is plan migration or plan failover. The purpose of this workflow is to move your VMs from the protected side to the recovery side while the protection side is still running. That means that before the hurricane actually hits you. If you're fortunate enough to have a stretched storage across your sites, this is where you would discover the most benefit of using stretched storage, because you can do this migration without any service downtime. If you don't use stretched storage, you still have guarantees of no data loss because we shut down VMs and sync and failover on the other side, but you will have some service downtime. If the disaster has already happened, or you think it has already happened, and you're not sure what protected site, in which state the protected site is, that's where you would use disaster recovery, which tries to do the same as plan migration does, except that if it cannot talk to the protected side, it assumes that it's down and continues on. If you're 100% sure that the protected side is down, then you would use the forced failover, in which case we don't even try to talk to the protected side. This saves you time and gives you faster recovery time or faster RTO. And if you want to test all of this, that's where you have the test and test failover and the cleanup, where we fail over VMs into the isolated bubble in isolated network, which you can play with, make sure that VMs are running, and then after this you can clean it up and do this once a month or once a week, how often you want to do it. And during all this time, the production side is still running and servicing whatever you need to, whatever it needs to be doing. And finally, there is the workflow, what we call reprotect. The purpose of this workflow is to reverse the replication and protection of your recovery plan after a failover. The main use case is, if let's say if you have a data center in Texas and you're anticipating a hurricane coming, so you migrate to some other data center somewhere up north, and then after this, when the hurricane leaves and you rebuild your data center, you want to go back home. And that's what reprotect is for. You reverse everything after the failover, essentially protecting back to your Texas data center. And after this, you can do test failover, and then reprotect again. With that, let me show you how test failover works. I'm not going to show how all workflows work. I'm going to show just one, test failover. It's fairly simple. You really just go to the recovery plan and you click a button, do a failover. Specifically for test, we have an option to, let me pause it here for a second. So you have an option to synchronize the latest changes from the protected side to the recovery side. I'm unchecking this here just to make it faster. And after this, the recovery plan will run and we'll do some things in the background. As you're watching it, for people who know SRM, you will notice that this recovery plan shows a little bit more information than SRM does today. More specifically, you'll notice that consistency groups are now first-class citizens. So you have progress for each consistency group. You see errors for them. Earlier, they were all grouped at the protection group level. Also, there's a few things like discovery steps and things like this. All these steps are there for a reason because we assume that everything is dynamic. So as part of failover, we try to do the catch-up protection, so to speak. That's why all these discovery things are for. So, and at this point, so the VM's already been, these writable snapshots of VM have been created, and then now they're being powered on. Once they power on, you have test VMs running in some isolated network, which you can play with. So let's compare the two types of protection groups. How are they different? How are they the same? Fundamentally, everything that is manual, this is all in legacy VM protection groups. Anything that is automated, it's all in SPPGs. They're both based on array-based replication, but vSphere replication goes only into the legacy VM-based protection groups. Anything that, like per VM overrides for inventory mappings or non-replicated disks, custom images, RDMs, all of that manual stuff has to go into legacy groups. We cannot do this with SPPGs because all of this requires non-trivial manual effort during the protection. With SPPGs, you get all the nice things about automation, but you also get all the new features like stretch storage supports and NSX integration. There's a couple of new things like Dynamically Protect and inventory elasticity, which I'll talk a little bit later. Otherwise, they're the same. They support the same workflows. They support the same recovery features, IP customization dependencies, inventory mappings, including the subnet-based rules. Let's talk a little bit how we determine where to mount data stores as part of the failover. For legacy protection groups, it's somewhat simple. The way it works is that when we protect a VM, we create a VM on the recovery side. We call it a placeholder VM. This VM is empty and has nothing in it. The only purpose of this VM is really just to reserve, quote unquote, place in the inventory. The initial placement is determined by the inventory mappings, but later on, you can move it around and override the inventory mappings. When we fail over data stores, we look where placeholder VMs are, and we mount the new data stores on all hosts in all these clusters. Let me show an illustrated version of that. Imagine that you have on a protected site a cluster with a resource pool in it, and you have a host with one VM and one data store. On the other side, you have a recovery cluster, resource pool, and two hosts. And in the beginning, there is no data stores. Then you map one resource pool to another, and then as part of the protection, we create a placeholder VM inside the mapped resource pool. So when we do a failover, we traverse from the placeholder VM to the resource pool, and then to the cluster, and from there we traverse to hosts, and then we fail over the data store, we mount this data store on the two hosts. So that's it for legacy groups. Now for SPPGs, let me just read it to you. A data store is mounted on all hosts in all clusters at the recovery site, which contain resource pool mappings from those clusters at the protected site, which contain hosts that can see the data store. If you understand this, you're in run session. You should be a lawyer. For everybody else, let me do it step by step with the illustrated version. So imagine that you have a protected site with two resource pools, two hosts, and data store is mounted on both of them. And then on recovery site, you have two clusters, each has a resource pool, and then you configure mapping from resource pools like this. Imagine, notice that we're effectively splitting the cluster into two on the recovery side. Obviously, we can do merge and things like this. So when we fail over this data store, first we see which host this data store is mounted on the protected side. From there, we go to the cluster, and then we go to all the mappings that are assigned to that resource pools in that cluster, and then we traverse them to the recovery side, and from those resource pools, we traverse up to the cluster level, and then we go to the hosts, and then we recover the data store and mount it on all these hosts that are in this cluster. This is actually important to understand because when SPPGs, the assumption is that you configure them and you forget about them. The next time you come to SPPGs is when you do a failover. Thus, you need to make sure that all your resource pool mappings are configured in the right way so that the hosts that you want to see data stores actually do see the recovered data stores. Now, one of the things that I mentioned earlier, which is a dynamic protect. The main difference between SPPGs and legacy groups is that the way we treat the VMs that show up on the recovery side after the failover but before the reprotect. Fundamentally, the problem is like this. Imagine that you failed over to a recovery side and now it's up and running. At this time, people start using it, start provisioning VMs, creating new data stores. Things will be different. And then when you restore your production site, former production site, and you do reprotect, what happens to all this new stuff? What happens to the new VMs and new data stores? The answer is different depending on which type of protection group you're using. If you're using legacy groups, then reprotect is really just a reverse. We take whatever we brought during the failover and we reverse that. So whatever data stores you had, the replication for them will be reversed. Whatever VMs you failed over, the protection for them will be reversed. But anything that outside of that will be considered not protected. You will have to protect it yourself. With SPPGs, it's very much different. Obviously, for things that we brought with us, we reverse replication for them through the array. But all the new stuff, as long as it's already in the storage profiles that were mapped, they will be protected. So all the new VMs, all the new data stores, everything will be protected automatically as part of reprotect. The only requirement here is that the data stores that are new have to be replicated by yourself because we don't know how to do this. Another tricky thing with SPPGs is what to do with tags. If you were listening to what we were doing before, tags play a very important role in how things get protected because they tie together data stores to storage profiles and fundamentally storage profiles tied to VMs, which means that you have to pay close attention to what you do with tags. If you're using array capabilities, these things will become a little bit easier, but let's assume that you have to deal with tags. And what you have to do is this. You have to create tags with matching names on both sides. You will have to create profiles on both sides and map them. It will be our responsibility to bring the tags from the data source on the protected side to the data source on the recovery side, and then map them together. But we will match them by names. And if you made a mistake, and if first time you will be doing it, most likely you will make a mistake. As part of the failover and the test failover, we will actually verify that what you did actually correct, and if not, we will give you errors and warnings about this. So just like earlier, let me give you an illustrated version. So imagine that you have a protected site, and you have a storage profile that uses a tag which belongs to a tag category, and you have a data store that has a tag attached, and they're matched with each other. And then you have a VM that associated with the profile and is placed on that data store. So what you would need to do on the recovery side is first you would need to create a category and a tag. And obviously this would do before you protect anything. Then you would create a target storage profile referencing this tag. And then you would map them, the storage profiles between each other. And after this, you can create a SPPG protecting the storage profile on the protected side. When we fail over, we bring up the data store and then the VM files that are on that data store. As part of the failover, we match the tags across by names and the categories by name. And after this, we assign the tag to the recovered data store, and then this will be matched to the storage profile, and then the VM will be associated with the storage profile. So that completes effectively the same picture as on the protected side on the recovery side. And these parts, creating a category and a tag and a storage profile, this has to be done by you. And as I mentioned earlier, if you made mistakes in this process, during the test failover or failover, we will flag this, and then you will have to fix it and rerun if necessary.
So, Alexei, if I'm using enhanced linked mode, does that change what I have to do from a tagging standpoint?
Yes, that's a good question. I forgot to mention this. This part about creating tags and categories, this can be automated. The answer to this question is what we call federation mode. If you have two vCenter instances between sites, you can federate them across. There is an option in vCenter nowadays for this. One of the side effects of this is that your users will be shared across data centers. And as applicable to SRM, the tags and tag categories will be automatically replicated across sites. You will not actually have to make sure that the tags are created to match names. You would still have to create the target storage profile, but that you would do only once. And presumably, if you're using policy-based stuff, you're not going to have hundreds of policies. You'll probably get a few.
And just to be clear, the way to configure enhanced linked mode in vSphere 6 is pretty simple. So vSphere 6, when you spin up your platform services controller on the SSO server, when you create your initial one, you'll create a site, an SSO site. When you add the second vCenter, what you would do is you would join that vCenter to the same SSO domain, but as a separate site. So by doing that, you'll create that enables the configuration of enhanced link mode.
That's the technical part of GS speaking. By now you should be wondering, why all this complications? Why all this tag management, mapping, and all this stuff? This is the answer. So if you've been falling asleep, then time to wake up and then listen to what this all means. The main purpose of SPPGs is really to deal with automatic stuff. This is what we call inventory elasticity. This is something that allows you to protect your data center as it lives through life. As things get added or removed through it, they will get protected automatically, assuming you did things right. And there's different rules that apply to different axes of the elasticity of your data center. First of all, about protected VMs. If you create a new protected VM and you associate it with a storage profile, it will get protected automatically. There's nothing that you need to do here, except for IP customization. We cannot guess what the new IP address for the recovery site will be. You will have to configure it manually, unless you're using either subnet-based rules or using NSX stretch networks. If you use any one of them, then protected VMs, you can add or remove them and it will automatically be protected. For the protected data stores, the story is a little bit simpler. when you provision a new data store, all you need to do is you need to assign the right tag to it. If you're using array-specific capabilities, that will actually be automatic completely. So it will automatically show up in the right profiles, and it will automatically be protected, and as VMs get placed to it, then they will be protected and replicated across. For hosts, both on the recovery and the protected side, there's really nothing you need to do. On the protected side, DRS will automatically redistribute VMs across and will automatically protect all that. On the recovery side, as long as you have the correct resource pool mappings, and that goes back a few slides where we're talking about where the data stores get mapped, this new host will automatically get the right data stores, and VMs will be recovered on them, and they will be running. For bigger entities in vCenter inventory, SPPGs are also elastic, but they do require some user action. More specifically, clusters. You can add clusters both on the protected side and recovery side, but you will have to configure resource pool mappings for them. If you don't do this, SRM will not know what to do with them. So that's an important manual step that you would need to do. Presumably, you don't provision clusters every day, so life as an SRM administrator should be easy. Tags and tag categories, that's another thing that may require some manual action, which is, as I've explained on the previous slide, you would have to make sure that they create it with matching names. And if you're using federation or link mode, well, not link mode, it's federation really.
Yeah, enhanced link mode.
Advanced link mode, right. Then this will be automatic. So just think about it. Imagine a life of SRM administrator where you spend a day, a week, or how long it takes to provision all this, configure this, and after this you really go on vacation for a year. Any new VMs that will be provisioned in your data center will be automatically protected. All you need to do is just run a test failover every once in a while from Hawaii. So, so isn't that cool? So with that, I'll go back to GS for some.
Yeah, we'll just do kind of a quick recap. So takeaways from this. SPPGs, just like Alexei was saying, just enable you to automatically provision, deprovision VMs. One of the things he walked through provisioning a new VM in a lot of detail. If you just storage vMotion a VM, it's going to give you that a very similar screen to what you see when you provision it, and that it'll let you select a policy, and if you select that storage policy, it'll show you the storage that's compliant with that. So just in migrating VMs, if you want to protect a VM, you just do a storage vMotion of it, associate it with the policy, move it to that protected data store, and you're done. That VM's protected just the same as everything else. So SPPGs are just going to make your life as an SRM admin easier. And the other big thing is that they enable the other new features of SRM. So if you want to use stretch storage and you want that NSX integration, you need to be using SPPGs in order to get that. So there's a few other SRM sessions. I don't have times associated with those, but these are the other sessions that I talked about the times earlier. And if you're interested, there's group discussions. If you've never done a group discussion, I would highly, highly recommend checking those out. Not just because me and Alexei are doing them, but because it's a small setting. There's going to be about 50 people in a room, and it's a lot more interactive. And it's something these sessions are recorded, so you're going to be able to watch these after the fact. You'll get the slides for these as well. But group discussions aren't something that's recorded. It's something that you can only do while you're at VMworld. So if you're looking for a chance to interact, ask questions, find out what other people are doing, that kind of thing, group discussions are a great way to go. So please fill out a survey. Especially if you liked the session, please fill out a survey. If you didn't like the session, just don't fill out the survey. No, really, if you didn't like the session, please fill out the survey. We'd love the feedback. We'd love to know what we can do to improve. And at this point, we'll take questions. So thank you all very much. Just raise your hand, and I think we've got some mics. Yeah. Well, I'll repeat the question if you're not at the mic. Sorry, where? Oh, where would it, what priority group is it going to end up in? By default, it will end up in the priority group 3. That's just by default where when you provision a new VM, and that's the same for any type of protection group. You provision a new VM, it's going to stick it in priority group 3, and then you can move it around as you want.
Yep. A little bit more detailed answer to the question. The question, by the way, was what happens to the new VMs that are protected, how they would be recovered. Obviously, there will be no dependencies configured for them because we don't know them. By default, there's a parameter in advanced settings which specifies what the default group is going to be. That's where I was mentioning that you need to think carefully how you're going to structure your VMs. If you know that certain VMs are really high priority, you should manually move them to tier 1 and tier 2. And the ones that you know not that important, move them to tier 4 and 5. And then put all the new VMs by default into 3, and at which point you can assume that they would have access to like Active Directory, database and things like this. If you need to override it later, that's where you have to come back from Hawaii and do some manual tweaking.
Okay. I have two questions. One is when you do a migration from primary site to recovery site from the storage perspective, SPPG, you automatically create VMs at the recovery site. But, right?
Well, you replicated the data.
And then turns up the new VMs at the recovery site.
The way it works is like this. SRM relies on some form of replication. This replication can be two forms, either host-based, which replicates at the software level in the host, or array-based replicates at the array level. So for SPPGs, it only has to be an array-based replication, which means that anything that drops on the LAN, on the array, gets automatically replicated to the recovery site. This can be either synchronous or asynchronous. That depends on how much money you pay to the array. As part of the failover, we talk to the array, and we bring up the replica LANs, we surface them, and then we mount them to vCenter, mount to the host that we discover through the resource pool mappings. And then we go find the VMs, because they're just files at this point, right? We find those VMs, we register them in the vCenter inventory, and then we power them on, customize and power them.
Okay.
Does that answer your question?
Yeah, I understand that, yeah. And in host-based replication, when you copy the VMs at the recovery site, how it will manage the data store, the data, how it will be copied?
For all like vSphere replication, any host-based replication, replication is, the target for the replication is specified as part of configuring replication. You actually pick the data store where you want to replicate to. So at that point, SRM will really just pick it up and surface the replica and register and then power it on.
Oh, okay. And sorry,
Go
one
ahead.
more. Before the tag management slide, you said that when you up the recover site and you create the new SPPG, for the new additional things, you cannot replicate that thing, even though it is available in storage profile. Why is it so?
Imagine this. You have a data store, just a very simplistic case. You have a single data store, you failed over to the recovery site, and you had only one VM on it. At this point, the data store is already there, right? So if it takes you a week to restore your original production site back to functional state, this data store is in your recovery site. At this point, if somebody comes in, one of your users comes in and creates a VM and places a VM on that data store, that VM is there. So it's because the data store eventually will be replicated back, it will be replicated back. But if you're not using SPPGs, it will not be protected. You will have to protect it manually. So the same happens for data stores. If you provision new data stores on the recovery side and you mark them with proper tags to point them into the recovery storage profiles, SPPGs will automatically protect them.
Okay. All right. Thank you.
Yeah, you're welcome. Yeah, please.
Two questions. When a VM is not compliant on the replication, is there a way to know how behind we are, like on time or megabyte or gigabyte?
Well, it depends on the replication. So if you're using vSphere replication will tell you if, say you have your RPO set to 1 hour, it will tell you if you're violating that RPO.
Yeah, but it doesn't say, it's not a way to know, how behind you are on.
Yeah, there's no way for it to tell you how far behind you are. You could, at that
Or
point,
any
you could-
estimation, nothing like that. Yeah, because it said.
You could set your RPO higher and see if that, how much higher you have to set it in order to resolve that issue. But yeah, there's not an easy way for it to tell you how far out of compliance you are.
Also, when you do failover, plan a failover, also there is no way to know how long it's going to take the synchronization.
That's,
Well, yeah.
we do the synchronization to bring the latest changes.
Yeah.
But how long it takes,
Oh.
really there is no way to predict.
Yeah.
Right.
For that
It's-
purpose, we
Or-
actually do two things. As part of the plan failover, we actually do two things, not one, two. And the reason for doing two is this. Imagine the simplistic workflow. We shut down the VMs because we cannot,
Yeah,
fail over the VMs.
that's-
Right? We shut
yeah.
down the VMs, then do a sync, and then recover and then power on. If the sync takes you a week, that means that during the 1 week, there's nothing is running.
Yeah.
And this week is not because the VM wrote too much on the disk as part of the shutdown. It's just the link has been down for a month. So there's a
Yeah.
lot of accumulated data to be transferred. So thus, we do an opportunistic sync before we shut down. We call it online sync. When we trigger it, everything is running. So everything is service and everything. If online sync takes a week, so be it. At this point, your VMs are running, your service and stuff. After this, after we shut down, do the second sync, the assumption is that the second sync will take a lot less time because the majority of data should have already been transferred as part of the online sync. And during the offline sync, after the shutdown, we will be transferring only the stuff that was written as part of the shutdown.
Yeah.
Does that answer your question?
Yeah, I think it's like, when you're going to do a plan a failover, like testing, we're testing.
Well, so are you doing a test or a planned?
No,
failover?
plan a failover.
Okay, so a planned migration. Okay.
Yeah, exactly. And, always management tell you, okay, so how long it's going to take, like, or we're going to do it on Friday or Saturday. I want to be able to fail bad by,
Right. Well, I mean, one way that you can get an idea of how long that's going to take non-disruptively is if you run a test. Remember, there's that little checkbox when you run a test that says synchronize recent changes. That's going to do that same thing. When you synchronize recent changes, it's going to synchronize the changes of the VM and then start powering them
Yeah.
on. And so if that takes a week, then you know that it's not going to work. If it only takes an hour, you'll have an idea that that's how long it's going to take when you run an actual planned migration. Does that help?
Yes.
Okay.
Thank you.
And just so you know, we've got just like 3 minutes left to take questions. We're more than happy. We'll take questions here, and then when we leave the room, we're happy to stand outside and take more questions. So.
Hi, maybe a quick one. In the beginning of the session, you said something about vVols. With vVols, SRM integration, SPPG would be the way to go with that. Can you say a little bit more about that?
vVols currently don't support replication. The thing I was talking about was stretch storage. So stretch storage is something where you can't now with SRM 6.1 you can utilize stretch storage. But yeah, currently the vVol spec doesn't support replication, so right now you can't use vVols with SRM.
And is it should we think about SPPG as perhaps a way to where that will be hooked up, or
For vVols?
Yeah.
I think it's a reasonable assumption. I can't I can't get any more detailed than that.
Okay.
So real quick, you guys have said that vSphere replication, you're calling it legacy in this context. Does that mean it's going away?
Well, no,
or?
so when he was saying legacy, he was referring to legacy protection groups.
Okay.
So legacy protection groups are just array-based replication and vSphere replication, and it's
Okay.
just legacy from the standpoint of SPPGs are new.
Okay.
And those,
So-
those types of protection groups are staying. vSphere replication's not going away. Yeah.
Okay, perfect.
It's if you remember my slide about the side-by-side comparison between the two protection groups, there's still a lot of things that you cannot do with PPGs.
Right.
Gotcha.
RDMs, custom devices, inventory overrides, all of that has to be done in VM protection groups. So if you were to say that VMPGs were to go away, then suddenly we would be taking away a lot of functionality from the system. That's
Gotcha.
not good.
Yeah.
So
and
that's why legacy means not like it's going away. It's just
Okay.
something that already there.
Okay.
Yeah.
Very good. Thank you.
Are there any vCenter alarms that you can set so that if you create a new data store, it'll automatically say that there's not a policy or tag on it, so that if you create a new data store, we know that it's automatically going to be protected in the future?
It depends on a lot of things. SRM by itself raises quite a few alarms in vCenter, so we can attach. email alerts to them and
Yeah.
things like this. But SRM does this for things that it knows it needs to protect. So like, for example, if a data store is already tagged to be in a profile and it's not replicated, then you'll get an alarm of some sort. If you have a VM that is in a profile but referenced in a data store that is not replicated, you get an alarm. But if you're just provisioning a data store, we don't know about it.
Yeah,
Right.
I think you might be. I mean, that's something that would be a vCenter alarm, but I think there's probably a way that you could generate an alarm for that. I mean, either an alarm or you might be able to write like a Power CLI.
Oh, yeah,
script
and just run a
that
script
would-
to report to you every day or something.
Yeah, you know, tell me about data stores that don't have
tags.
or something like that. Yeah.
Okay.
There is a trick for this. The trick is this. If you look closely to the videos that I showed, if you look at the tags that were assigned to some of the data stores, some of them were saying like replicated, SRM consistency group and stuff like this. So these are tags assigned by us, by SRM. What we do is we monitor the arrays that you configured SRM to work with for any data store consistency group that is replicated. We find them in VC and we tag them. We do this for different reasons. So specifically for SDRS integration and all this stuff. So if you run a script that goes through all your data stores and it sees a tag replicated, that means SRM thinks that it's replicated. And then if you also look for tags that you use, and if you see that they're not there, raise a red flag.
Okay. All right. Thank you.
Yeah, and just so you know, it's 2 o'clock now, so they're going to kick us out here in just a second. But like I said, we're happy to keep taking questions just right outside the door. So, thank you all very much.